Okay, for question 6 of forces, it says determine the acceleration of the blocks in scenario of one above. That is this one. So there's only actually going to be one acceleration because that together, each box is a system, but when it's put together, it's a system all by itself. So I'm going to look at the equation where it was talking about force friction plus force tension equals force net. So I asked Mr. Middleton what we should do about friction, and he said assume there is no friction. So we're gonna convert the only source of tension that there could possibly be, which would be the 2 kilogram mass that's going down, into newtons. So I do that by timesing 2 kilograms times 10 newton per kilogram. The kilograms cancel out, it gives you 20 newtons, which is equal to the force tension, which is equal to the net force. We know that Newton's second law says that force net equals mass times acceleration, right there. So that means that 20 newtons is equal to mass times acceleration. So how we figure out the mass is because the whole system, we have to find the whole system mass. So up here, in the previous problem, we had to break it down into two different ones because each one had, each one had a net force at the end, but each one was kind of its own thing. Now it had different forces working on it. Now we're kind of combining it into one equation. So we have to add 2 and 15 because it's the whole thing. Because the whole thing will be moving at the acceleration. I mean the 2 kilogram block, because they're attached by a string, will be moving at the same acceleration. So when you add 2, let's say that's kilograms or whatever, plus 15 kilograms, you get 17. So when you have that, you have 20 newtons equals 17 kilograms times acceleration. To solve for acceleration, you divide 17, or you divide 20 by 17. 20 newtons divided by 17 kilograms, and then you get an acceleration of 1.177 meters per second squared. So that means that this little thing will be moving at an acceleration of 1.177 meters per second squared.